In the book, on page 98, in the chapter of Further Organic Chemistry, we are going to study isomers. First of all, we have structural isomers. Two molecules are structural isomers if they are made up of the same type and number of atoms, but these atoms are arranged in different bonds. Although they have the similarities of the type and number of atoms, they are completely different molecules just because of their different arrangement. We also have geometric isomers. They have atoms arranged differently in 3D around a double bond. So they don't have to have all of their atoms arranged differently like structural isomers. They just have to be arranged differently around the double bond that exists in the molecule. If atoms around the double bond are on the same side, the molecule is cis, like here in A. If they are on opposite sides of the double bond, the molecule is trans, like here in B. An easy hint is to connect the atoms that are similar around the double bond. If they are cis, they will make the shape of an E. If they are trans, they will make the shape of a Z. Another type of isomers is optical isomers, or enantiomers. They are mirror images of each other. We call them chiral molecules because they are asymmetrical. They do not have a single center of symmetry. An example of a chiral molecule is a carbon atom attached to 4 different atoms. The carbon atom here is called the chiral center. Because the molecule is chiral, it does not have a single center of symmetry. And here the carbon is called a center of chirality or a chiral center. Chiral molecules are represented differently, so we can understand which enantiomer we're referring to. Here we see 2 chiral molecules. We see the line representing the atoms that are going through the plane of the paper. The dotted lines are going behind the paper. The wedges, or the triangle shapes, are in front of the paper. And that gives us the x, y, and z dimensions. I am now going to use the simulation that allows me to build a molecule to further explain structural isomers. This is propanol. It has 3 carbon atoms, 1 oxygen atom, and 8 hydrogen atoms. This is the structure of 1-propanol, or propan-1-ol. To make a structural isomer of 1-propanol, I'm going to keep the same atoms, but I'm only going to change their bonds. So instead of having the oxygen bound to the first carbon, I'm going to bind it to the second carbon. This becomes 2-propanol, or propan-2-ol, which is a structural isomer of 1-propanol, a different molecule.